So welcome everybody to this latest video on 162 Maths, and in this video we'll be working through some AQA GCSE Maths Foundation topic tests with a focus on standard form. Now as always there'll be a copy of the test paper in the description below for you to download and have an attempt at either before watching this video or while watching this video as we go through the answers. Now it's worth mentioning before we get started working through this topic test on standard form that the first section is a calculator section and the second part is a non-calculator section, as standard form can appear on both the calculator and non-calculator paper. So let's get started. So for starting with the calculator section, it says for question 1, it says here are 5 numbers, work out the difference between the largest and the smallest number, and this question is worth 3 marks. So the first thing we want to do is we want to convert these into the same form, and I would always recommend that when you're ordering numbers in standard form is, unless the powers are the same, I would convert them all into ordinary form first. Let's do just that. Now a few already done for us. So this number here is going to be 4, 5, and it's going to be with 3 zeros. This one here is going to be 5 with 3 zeros, and this one's going to be 2, 8 with 4 zeros. And then here we've got 1, 2, 5, 0, 0. Don't know why I'm writing that one down. And while we're at it, might as well write this one down. So looking at these 5 numbers, I should be able to spot that our smallest number is 5,000. And our largest number is going to be 280,000. So then I'll need to work out the difference between the two numbers. So it's going to be 280,000 minus 5,000, and that gives me an answer of 275,000. Now the key thing is that it also says to give our answer in standard form. So though this is the answer, I then need to convert that into standard form. So that's going to be 2.75 times 10 to the power of 5. Moving on to question 2, it says work out, and then here we can type this in. Now let's get the calculator out. So for this, we can either enter it as it's written in the question, or we can use our standard form button. Now if you're not going to use the standard form button, just make sure that you are using times, you are using the brackets, and you are using your universal power button, which is this X with a little box next to it. However, I'm going to go for the standard form buttons. Now when you're using the standard form button, brackets are going to be optional. The only reason why there are brackets written in the question is purely just to identify that it's not a BIDMAS question, it's a standard form question. So here I'm going to enter 5.9, press the standard form button, then enter the power, which is 7, close the bracket, divided by, open bracket, 2.3, standard form button, 4, close bracket, equals, press the SD button, and it gives me a long nasty decimal number. Now that decimal number is going to be 2565.217391. Now the question says give your answer in standard form to 2 significant figures. So if I round this number up to 2 significant figures, then that's rounding up to nearest 100, so that's 2,600, and then that in standard form is going to be 2.6 times 10 to the power of 3. Now on the mark scheme they do accept 3 times 10 to the power of 3, but I would always opt for this one being the more accurate answer. Moving on to question 3, it says to solve this equation. So here we want to get x by itself, so what I need to do is get rid of that 0.02 by multiplying by 0.02. So here x equals 3.1 times 10 to the power of minus 4 times 0.02. So again, I could enter that purely on the calculator without using the standard form button, or let's just use it as it's potentially the only time I'm going to ever use it. So minus 4 multiplied by 0.02 again gives me a decimal answer, and it's actually converted it into standard form for me already. So it's 6.2 times 10 to the power of minus 6. Then looking at question 4, it says here are 2 probabilities of 2 independent events. And I don't know why that's shifted, so let me move that across there. And it says how many more times is event A than event B. So what we need to do is do some dividing. So here we're going to divide event A over event B. So that's going to be 2.7 times 10 to the power of minus 2, all divided by 3.4 times 10 to the power of minus 4. Now, if I enter that into my calculator, either as a fraction or using the division symbol, I should end up with 79.41 blah, blah, blah. So basically, how many times bigger is it? Well, it's either going to be 79, or in the mark scheme, they do accept 80, but I would say 79 is probably going to be the option. Actually, 80 would be as well. So there's a justifiable cause to give you either of those two answers. Now we move on to the non-calculator section. So the question says for number 5, it says circle the number that is in standard form. And out of these, so number 1 isn't in standard form because of this 5. Number 2 is not in standard form because of our first number. It needs to be between 1 and 10. 3 is our correct answer, and the reason for the fourth one not being in standard form is because that number there needs to be a number less than 10, not 10. Question 6 says write 32 million in standard form. Now million has got 6 zeros, so it's 32 with 6 zeros. So then we need to write this in standard form, so that's going to be 3.2 times 10, and counting the decimal points, so 1, 2, 3, 4, 5, 6, 7, and there is our final answer. Then moving on to question 7, it says write 4.12 times 10 to the power 6 as an ordinary number. So here with small numbers and negative powers, the power basically represents the number of zeros that we're going to have at the front. So here we're going to have 6 zeros, so 1, 2, 3, 4, 5, 6, with a decimal point after the first 0, and then we just copy that A number down as it is. There is my final answer for that one. Then with question 8, it says work out 5 times 10 to the power minus 3 squared. So that is 5 times 10 to the power of minus 3. That's really important that you do recognize this as a double bracket question, where we just need to do these. Now from this, we don't need to do any cross multiplying because this represents just one number. So 5 times 5 is 25 times 10 to the power 3 times 10 to the power of minus 3 rather. So here we add the powers, working with indices. That's 10 to the power of minus 6. Now at this moment, this is not in standard form because this number needs to be smaller. So if I make the 25 smaller to make it 2.5, I need to make the power bigger. And so what's minus 6 plus 1? It's minus 5. Then moving on to our last set of questions, it says that the table shows the surface area of 6 planets, and the question is asking circle the planet with the smallest surface area. So again, what we want to try and do is to try and neatly convert all of these numbers into ordinary form. So this one's going to be 8, 1, and then it's going to have 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. 4, 6, 0, and then million has got 6 more zeros, so 1, 2, 3, 1, 2, 3. Then we've got 6, 2, and then with 9 zeros, so 1, 2, 3, 1, 2, 3, 1, 2, 3. Then we've got 7, 6, 4 with 7 zeros, so 1, 2, 3, 4, 5, 6, 7. Then we've got 1, 4, 5 with 6 zeros, 1, 2, 3, 1, 2, 3. And then finally for F, 4, 2, 7, and that's going to have 8 zeros. So 1, 2, 3, 4, 1, 2, 3, 4. So which one of those numbers is the smallest? And the correct answer we should have is E. Which of these is the biggest answer? And the correct answer should be C. Then moving on to our last question, it says the area of Earth covered by water is 361 million kilometers squared, and square kilometers rather, and the area of the Earth not covered by water is 149 million square kilometers. What is the total area of Earth? So here what we need to do is add these numbers up. So 361 million is 36, and then 1, 2, 3, 1, 2, 3, and 149 million is going to be this number, and we need to add the two numbers together. So these are all going to be 0, that's going to be 10, that's going to be 11, and that's going to be 5. So we need to convert 510 million. So converting this then into standard form is going to be 5.1 times 10. And if I just count the number of decimal places, so 2, 3, 4, 5, 6, 7, 8. and that's going to be 8 there, and there we go.